Okay, we are back. Alright, and the cat has been chased out of the room. Okay, come. This one I realize has given a lot of you a lot of problems. Okay, so I'm gonna spend a little bit more time on this. Alright, this is an example of asking the computer to do something that is, like tremendously difficult to do on your own. Alright. Hopefully you remember the sieve of Eratosthenes from your primary school maths. Alright, it's an algorithm to find all the prime numbers up to some limit n. Okay, so let's say you start with a list of numbers from 2 to n, 2 to 100. Alright, you get rid of the first number. Alright, then that's a prime number. Alright, then you remove all multiples of this. So anything that's divisible by 2 from 2 to 100, you get rid of it. Alright, sorry, this should be n, not 5. Sorry. Alright, then once you're done with that, you're left with 3, 5, 7, 9. If you got rid of all the even numbers, right? Then you remove 3. Right, remove 3. Alright, here it is. Alright, remove 3. Then 9 is removed. 6 is already gone. Right, so you leave 5 and 7. Alright. Then 5 is prime. There are no more multiples of 5. 7 is removed. Okay, and then we are done. Alright. So one of the problems that you guys have been facing in this particular problem is that you get the idea. Right, you get the idea. You have a n equals to 1, range 2 to 100, for example. Alright, sorry, the list equals to range this equals to range 2 to n. Alright, let's not call it this, let's call it sieve. Alright, where n equals to 5. Oops, that's me encoding the other video. Alright, so yeah, n equals to 5 kind of stupid. Let's do n equals to 50. Alright, so what you do is for I in range 2 to n, alright, then you remove the first item, and then some of you get confused at this point. Alright, what am I going to do now? Alright, you actually need to loop. Alright, so think of this step by step. Alright, step by step. Loop through remaining items. Okay, look for multiples of I, which is currently I. Look for multiples of I. Remove them because we don't want them anymore. Okay, and then let the loop continue. So a lot of you get tripped up by this, alright, partly because of the way for loops work. Alright, you end up with a lot of index out of bounds issues. Okay, so let's see what's going on. So if you do something like for I in sieve, alright, so let's say you have a list of primes. Alright, a list of primes. Alright, and primes equals to primes plus I. Alright, so great. Then what you want to do is you want to loop through for I in, not I, right, for like multiple in range I plus 1 to n, alright, for example. Right, let's use range 2 n here. Okay, so what you do is, okay, you loop through again, alright, and then you go ahead and if multiple is divisible by 2, well, no, not divisible by 2, divisible by I, alright, then you actually go ahead and delete that item. Alright, so delete, let's say, sieve bracket multiple. Something like that. Alright, I'm doing this off the top of my head. Alright, and then you hope that this works. Alright. However, one problem is that as you are deleting, first you start with 2, 3, 4, 5, 6, 7, blah blah blah. Alright, as you are deleting, you end up with 3, 5, 7. The problem is that the length of your list has changed. Let's say this was 50, right? So the length of this is 49. Now we've removed all the even numbers, so I assume we have about 24 left. 25. Alright, 25 left. 23, 24, something like that. My math's very bad. Failed PSLE. Okay, so what happens then? Alright, the problem is that when the next value that I takes on is 3. Sure, that works. Alright, you will remove, you're going to look from here onwards. Alright, you're going to look from, 3 onwards. Alright, but then the problem starts showing up later on when your I takes on the value 4. Alright, when I takes on the value 4, what are you going to do? Okay, and at some point it's going to look through the whole stupid thing 49 times, even though your list is shrinking and shrinking and shrinking. Alright, so this is an important thing to note. This thing is fixed. It's not going to adapt to the new size of your loop. Okay, if you want it to adapt to a new size of your loop, you can use a while loop. Alright, you can say while the length of a sieve is some, I don't know, or length of a sieve is less than, is not equals to 0. Not equals to 0. Alright, then you keep on deleting from the sieve, alright, until you get something. Alright, that's one way. I'm going to show you the other method, which is the method that I ended up using once I find it. Exercise 6-3. Okay. Alright, let's start from the very beginning. N equals to integer blah blah blah. Okay. So then we have one called nums and one called primes. Alright. I start by creating an array of nums. Actually, I don't even need to do this. Like, I can just say nums equals to range 2 bracket whatever. But never mind. Alright. Let's do that anyway. So what I'm going to do, let's pretend that I'm writing this step by step. Alright. So I'm going to say, I'll comment this out. I'm going to run this, and I'm just going to make sure that, you know, I have the correct numbers, because you know, who knows, you write a whole bunch of stuff, then you realize, my nums was defined wrongly, you know, I put 2 comma n instead of 2 comma n plus 1. Alright, so again, I stress to you guys, I know you all don't like to do some of these things, but I've told you many times, the things you should do are, alright, work in steps, work in small steps, alright, and the other thing you should try is, please try pen and paper, for goodness sakes, alright. Try pen and paper, draw it out, figure out what's going on. Alright, staring at your screen is not an easy way to do things. Okay? Alright, so in this case, I am using a while loop. Alright, so I'm saying while this thing is greater than 0, alright, so while the size of my numbers list is greater than 0, I'm going to add the first thing onto my primes list. Alright, I create a set of new nums to loop through. Alright, this is might just be a safety thing, but let me check. Alright. Then I loop through the old nums. Alright. Notice how I loop through nums, but I am, instead of deleting from nums, I am creating a new set of numbers. Alright, let me repeat that again. So new num starts off empty, but as I loop through it, I'm just adding the things that are not multiples. Alright, instead of deleting from the ones that are multiples. Does that make sense? Alright, again, I start with empty. Alright, if the current one is not divisible, then I add it to the new list. When I'm done with this, I should have 3, 5, 7, 9. Alright, I should have 3, 5, 7, 9. And what I'm going to do is I'm going to make a copy. Alright, remember, you cannot just say nums equals to new nums. Alright, this will give you a bit of trouble later on. Okay, because if you do that, alright, if you change either one, the other one will change. Alright, so you want to make a copy. This is how you make a copy. Alright, or you can make a copy. Right, I guess nums.copy. Alright, so yeah, you can do copy as well. Alright, copy, open bracket, close bracket. Okay, so, and all these things, because I was trying to solve this just like you, right, and I wasn't sure what's going on. Sometimes I made mistakes. So what I do is I add print statements. I say, as the loop is going on, print out, alright, give me a status update. What is primes, what is nums? Alright, so let's run this. Okay, so I want to check to 100. Okay, so what it's doing is, it is just looping and looping and looping and looping and cutting away. Alright, so this is a bit hard to read, so what I'm going to do is I'm going to say print the empty line in between. And over here I'll print the empty line and I'll say start. Alright, then print another empty line. Alright, so let's start this. Let's not do 100 anymore, let's do 40. Okay. So as you can see, the way this is going, alright, so I've made it easy for me to read. Alright, I've made my debugging easy for me to read. Alright, I'm not guessing and looking at the final result and going, oi, how come it's like that? Or oi, how come it's crashing? Alright, I'm printing out things as I go along. So I start with, oh, it's 2, and it's gotten rid of all the multiple of 2. Oh, it's 3, it's gotten rid of all the multiple of 3. 5, gotten rid of all multiple of 5, etc, etc, etc. Okay, fair enough. Alright, and essentially when nums reaches 0 length, it quits, and I print out the primes. Okay? Alright, that is the sieve. Alright, if you're still not sure, please come and look for me. I will explain in greater detail and, complain about things. Alright, the last one, alright, is to write a function called flatten list. Alright, flatten list takes in the input as a list which may have more than one level. Alright, and after that, it creates a simple flat list. Okay, so this one requires something called a type. Right, you need to look for a type. Okay, There's a hint over here and stuff like that. Well, actually, might not need to. Okay, well, let's look at the answer for 6-4. Okay, this is the non-extension version, alright? You can look at extension later. This one essentially, okay, first of all, you need to check the type, alright? What is the type of this, right? It's an int, but it's not very helpful for you, alright? So what you can do is, as you are looping through a list, okay, you get an item, alright? What you can do is you check the type of an item against a list, or you can check it against type bracket 1. Alright, then you know whether it's a list or a simple integer. Okay, so in this case, I don't think I didn't tell you that these are definitely integers. So we just check whether it's a list. If it's a list, alright, if it's not a list, then you just add it on. If it is, alright, if it is, then you loop through the inner list. So you really have to get used to adding loops inside loops. Alright, so you have a loop and a conditional followed by another loop, right? So if it's a list, then we just we assume that that everything inside those are items, alright? Then we just then we just add them on. Alright, so this is a simple version. The second one, alright, how about any level of nesting? Alright, so this is the second version. Alright, here's a version that uses recursion, which we'll go through next week, or depending on when you listen to me, because time travel. Woo! Alright, so this says that new list equals to blank list, same as above. For item, if it's not a list, then you just add it on. Otherwise, you add the flattened version of this item to the list. Notice that I'm calling the same function as I am in. Ooh, magic. Alright, but if your function behaves properly, what it should do is, alright, it should take the item, alright, and it should flatten that. Alright. And at some point it will reach an item that's not a list, then you add it on. Okay, so this is why it works. Alright, so very simple. Yeah, well, not say simple. The last one is a non-recursive version. Alright, I'll post these solutions online at some point. What this does is it loops through the list. Alright, then it just it does a while loop to loop through this, and then it does a while loop inside there as well, right? Inside each item. Okay. So yeah, it's a little bit strange and confusing, but it works. Okay. If you're interested, you can study this. I don't expect that we'll ask anything this difficult. Alright, but let me just run to make sure that things do work. Okay, so notice that this one flattened a gigantic list into this. Similarly for the recursive list. Okay, that's it. Bye!